Equilateral triangle. Let us study how to work out the area of an equilateral triangle. Do you know how to use Pythagorean formula to find area of an equilateral triangle? The area of a right angle triangle can be found using the Pythagorean formula. In triangle PRQ, PQ square is equal to PR square plus RQ square, as PQ is the hypotenuse. What is Pythagoras' theorem? In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides. Let us study how we use Pythagorean formula to find area of an equilateral triangle. The area of an equilateral triangle can be found by using the Pythagorean formula. Let us consider equilateral triangle ABC of sides A unit. Draw the perpendicular bisector from angle A to BC. Perpendicular bisector AP bisects BC into two parts. BP is equal to PC is equal to A by 2. Now we can apply Pythagorean formula to find the area of this triangle. In triangle ABP, A square is equal to A by 2 square plus H square. This is derived from the Pythagorean formula. Therefore, A square is equal to A square by 4 plus H square, or 4A square divided by 4 minus A square divided by 4 is equal to H square. Therefore, 3A square by 4 is equal to H square, and H is equal to square root of 3A square by 4, or square root of 3 multiplied by A divided by 2. Height of an equilateral triangle is equal to square root of 3 multiplied by A divided by 2. Area of an equilateral triangle is equal to half multiplied by base multiplied by height, which is equal to half multiplied by A multiplied by square root of 3 multiplied by A divided by 2. This is equal to A square multiplied by square root of 3 divided by 4. So the area of an equilateral triangle is equal to A square multiplied by square root of 3 divided by 4. Suppose the triangular arc is an equilateral triangle with sides equal to 10 meters. How do you find out its area? Let us learn to find out height of a triangle when we know its sides. Let us name the triangle as PQR. Mark the midpoint M on QR. Join P to M. Triangle PMQ is a right triangle. Using Pythagoras' theorem, we can find the length PM. In triangle PMQ, PQ square is equal to PM square plus QM square. Therefore, 10 square is equal to PM square plus 5 square. Because QM is equal to MR is equal to 10 divided by 2, which is equal to 5. So, 100 is equal to PM square plus 25. So, PM square is equal to 100 minus 25, which is equal to 75 meters. So, PM is equal to square root of 75, which is equal to 5 square root of 3 meters. Now we know height and base of a triangle. Let us calculate the area of this triangle. In triangle PQR, height PM is equal to 5 multiplied by square root of 3 meters and base QR is equal to 10 meters. So area of triangle PQR is equal to half multiplied by base multiplied by height, which is equal to half multiplied by QR multiplied by PM. This becomes 25 multiplied by square root of 3 square meters. So the area of triangle PQR is equal to 25 multiplied by square root of 3 square meters. If the sides of the triangle are doubled in length, what is the triangle's new area in terms of the original length of each of its sides A? Solution. Area of an equilateral triangle is equal to A square multiplied by square root of 3 divided by 4. If the sides of this triangle are doubled in length, then A changes to 2A. Area of the new equilateral triangle with the sides double to the original length of the side is equal to square root of 3 divided by 4 multiplied by square of sides, which is equal to square root of 3 divided by 4 multiplied by 2A whole square, or square root of 3 multiplied by A square. Suppose you triple the sides of this equilateral triangle. What is the triangle's new area in terms of the original length of each of its sides A? Solution. Area of an equilateral triangle is equal to A square multiplied by square root of 3 divided by 4. If the sides of this triangle are tripled in length, then A becomes 3A. Area of this new equilateral triangle is equal to square root of 3 divided by 4 multiplied by the square of the side, which is equal to square root of 3 divided by 4 multiplied by 3A whole square, or 9 multiplied by square root of 3 divided by 4 A square square units. What is half the area of this triangle if A is equal to 4 centimeters? Solution. This is an equilateral triangle. So using the area of an equilateral triangle from the formula, the area is equal to A square multiplied by square root of 3 divided by 4. If we substitute A is equal to 4 centimeters, the area of the triangle becomes 4 multiplied by square root of 3 square centimeters. Now half the area of this triangle is equal to 2 multiplied by square root of 3 square centimeters. Find the area of an equilateral triangle with a perimeter of 24 centimeters. Solution. Perimeter of an equilateral triangle is equal to 24 centimeters. So the sides of this equilateral triangle is equal to 24 by 3 as all the sides are equal. So each side of this equilateral triangle is equal to 8 centimeters. If we draw a perpendicular line from A to BC and mark the intersection of this line as D on BC, then BD is equal to DC is equal to 8 by 2, which is equal to 4 centimeters. In triangle ABD, 8 square is equal to 4 square plus h square. This is from the Pythagorean theorem. So, h square is equal to 64 minus 16 or 48. Therefore, h is equal to 4 multiplied by square root of 3 centimeters. Now, the base is 8 centimeters and the height is 4 multiplied by square root of 3 centimeters. We know that the area of a triangle is equal to half multiplied by base multiplied by height, which is equal to half multiplied by 8 multiplied by 4 multiplied by square root of 3, or 16 multiplied by square root of 3 square centimeters. An equilateral triangle is placed on top of a regular hexagon as shown in the figure. Find the area of the entire figure having sides equal to 6 units. An equilateral triangle is placed on top of a regular hexagon as shown in the figure. Each side of the hexagon is 6 units. Regular hexagon can be divided into 6 congruent equilateral triangles. In the figure, total number of congruent equilateral triangles is equal to 7, as another equilateral triangle of the same dimension is placed on top of the regular hexagon. So area of the equilateral triangle is equal to a square multiplied by square root of 3 divided by 4. In this case, the area of any of the equilateral triangles is equal to 6 square multiplied by square root of 3 divided by 4, which is equal to 9 multiplied by square root of 3 square units. So the area of the figure is equal to 7 multiplied by area of an equilateral triangle, which is equal to 7 multiplied by 9 multiplied by square root of 3, or 63 multiplied by square root of 3 square units. The cube has edges of length 1 unit. Find the area of triangle ABC. In the figure on the screen, the length of two sides of triangle ADB, triangle ADC, and triangle BDC is 1 unit. Each triangle is an isosceles right-angled triangle. The hypotenuse of each right-angled triangle AB, AC, and BC is equal to square root of 2. In triangle ABC, AB is equal to BC is equal to AC, which is equal to square root of 2 units. Therefore, triangle ABC is an equilateral triangle. Area of an equilateral triangle is equal to a square multiplied by square root of 3 divided by 4. If we substitute a for square root of 2, we get the area of the equilateral triangle ABC equal to square root of 2 square multiplied by square root of 3 divided by 4, which is equal to 2 multiplied by square root of 3 divided by 4, or square root of 3 divided by 2 square units.